It's really nice to be here. You can see as a presenter, usually you have the problem of keeping your data up to date. My problem was when I left my home recently, it was fall. So I used fall leaves for my presentation, but I got here and it was snowing, so maybe it should be snow on my presentation. I've been in North Bay before. I know how cold it is usually, and I came prepared. So, containerized systems. I'm going to talk very briefly about projects that are really about implementing projects quickly, safely, and quite efficiently. A lot of the times when you're looking at presenting or producing projects and implementing large boiler or biomass systems, you have a logistical problem and an implementation problem, because most boiler rooms, if you're going to add a biomass boiler or change out a boiler, you have an awful lot of work to do. You've got downtime between swapping out boilers, you've got other considerations. Space is a usual problem. With containerized systems, we can look at a simpler way to implement. There are also some political and well, PR type things you need to look at in the marketplace, especially when like a new market with Canada, where people like mayors, cities, towns, those sort of places actually need to look at the politic of what goes on. So it's important that you actually grasp it cleanly and make a good impression. I'm impressed by what Massachusetts is doing, and I'd love some of those rules and directions here. The one thing I do like is the idea that heat is actually an item you can get grant against, and you are actually credited for it. I swap these words on a regular basis, so when I talk about fuel or biofuel or whatever, I mean the things we can burn, and I'll come to the detail of that in a moment. General biomass systems are capable of using quite a multiple range of fuels. If you look at the larger end systems, those that are running power generation, typically in some areas or some countries you're using pellet for transportation, then you'll crush it and then it will be used as a powder. In others you're going to be using wood chip. So generally in larger systems, big power generation or big commercial, you make a choice and you stay with that fuel. With the smaller systems that I'm talking about for things like pilot schemes, and really pilots are a good way to implement in a new market. With those pilot schemes, you need a flexibility on fuel, mainly because of availability. I mean, we've seen in North Bay a change where last year there was a shortage of fuel, and if you had a pellet boiler and there were no pellets available, you had no heat from it. It was difficult to get pellets. If you've got a boiler or a biomass system that can change, and it can change without calling a technician out, then you're onto a plus. All the systems generally are computer-controlled systems. If it's not computer-controlled, then really you shouldn't be buying it. There needs to be a control system and also a change in the way that the marketplace and the operation of boilers works. In most of the Canadian side of things and also in the USA, it's quite clear that generally the rules are about maintaining boiler engineers 24 hours a day on a site once you reach certain limits. In Europe, what happens is a farmer, typically a farmer in Europe, will buy a biomass system for his farm. If he is close to a village, he will sell heat to that village. It's not a biomass engineer that's operating that plant. And the comment made earlier about it's a consumer that's dealing with this, the farmer does not want to be in that biomass area working every day. So he turns it on, sets it, and leaves it. And most biomass boilers now actually operate like an oil boiler or a gas boiler. Completely computer-controlled, automatic. This is always a key one, no smoke. At the moment, there's a biomass boiler outside, out the back, actually running if you go out through the back door. And if you look at the smokestack, it's running, and there is no smoke up there. And that's because it's burning efficiently. We've all got this concept. We talked earlier, earlier about smoke and being a bad neighbor. This is one of the key issues in Europe. You cannot pollute, and it's not acceptable to pollute in any way, shape or form in Europe. We all live right on top of each other. Canada has a nice big space, but you can still be a bad neighbor. So computer-based systems and burning correctly will give you a clean system. Typically the systems I'm talking about aren't power generation. We're talking about heat-based systems, so it's hydronics, and you're using biomass to create heat in water or a fluid and then moving that fluid elsewhere. In many places, I know in Ottawa there are buildings, small subdivisions, even down to small blocks of buildings that are actually being heated with a localized heat source. So it's very small micronet type systems or district heating systems. They vary in size, but it's the same principle. It's transporting that heat to the locations. These units that I'm talking about, again, do not produce electricity. On all of the biomass systems that I've seen throughout Europe and the Canadian and US marketplaces, filtration is an issue. Right? Output gases and output particulates are a problem to lots of people. There are lots of perceptions that will cause you problems. I love the comment about particulates here. It's really a big issue. In the European marketplace, we have regulations that are tighter than some of the things you're proposing here already. I know with Vancouver Metro, I mean, they're talking about very low numbers, partly to give a good output and a good PR wrap to the boiler systems, but also it's about not wanting a biomass system that could be perceived as generating waste or particulates within the city boundary. If someone was running their washing and hanging it up outside, they do not want to bring that thing in black. So it needs to be clean. We need to be a clean industry. We can't start out where coal started and be dirty from the beginning and clean it up. It's not acceptable for us. I talked about different fuels. Systems now need to operate. The two key fuels that we're talking about are either wood chip at sensible moisture content levels or pellets. Generally, this is about producing a fuel and the availability and locality of the fuel. So if you're going to be transporting fuel any distance, you need to densify it in some way, whether it be pellets, briquettes, or that sort of densification, and then you can ship it. You do not want to be transporting water. Some of the larger biomass systems will actually run fuel up to 55% moisture content chipped. In Europe, we've got systems that you can chip a tree, a raw tree, and burn the fuel. But it's not efficient. And it's certainly not efficient if you want to move fuel. Question is, do you have to change or choose a specific fuel? In the larger systems, yes. Again, if you look, the Brandel system outside is actually a user selectable system. So if you happen to have the availability of wood pellets and you can get them at a good price, that's fine, you can select that. If you, as the end user, want to change to a wood chip, or dare I say, no fuel is available, you can go and cut cordwood and put it inside of the system and it will burn it. They can burn things like corn. It's a flexible process, but because it's all computer controlled, you can actually use it and choose it as you wish. The system will deal with the variability in that. Fuel quality standards. A long while ago, I was at a meeting and I rattled Mr. Smitherman's cage over standards in the country on fuels. At the moment, there are lots of talks about fuel levels. The one thing that's happened in Europe is there are defined fuel standards. It does two things. One, it means that a defined fuel standard says boiler manufacturers can actually manufacture a system that is very efficient. Europeans work at that standard and they actually work to the standard. We even have standards for how you can transport and move pellets and how you can deliver them. So if the man comes to deliver your pellets and he blows them into the fuel storage too quickly, he's breaking the rules. You'll still get 30 tons of pellets delivered, but if it's blown in there too quickly, it will be waste dust inside the storage silo. So we have standards for that. It's important that Canada looks at, people like CanBio and lots of the associations that are here have got good views on this stuff, but you do need to try and implement something. And it's better if you can implement early rather than late. Moisture content is always an issue. Pellets, it's always a low content, but the variability is a problem. When you're working with wood chips, it's, again, because there's no standard. I've seen locations where on one side of the street is a greenhouse running, quotes, wood chips, and on the other side, they're running exactly the same biomass boiler, running, quotes, wood chips, but neither of them can exchange fuel because his boiler is configured for very small pieces of very dry fuel, and his boiler is very wet fuel and very large. So standards would help. It also helps on pricing because you can ring, if I'm in Europe, I can ring 5 different locations that could be in any of the European countries, and I can compare like for like in every location. So if I ask for an O-norm standard pellet from one company and I see it's a price, I know I'm comparing exactly the same object. So end users benefit from that as well. Why would you containerize a boiler system? Well, as I said initially, when you install a biomass system, typically you're putting it inside either a boiler house or another building. And part of that process, certainly at this time of the year, if you have engineers on site and in and out of the building, it's difficult to do. The weather slows them down, there are difficulties with installation. With containerized systems, you can actually bring a container and place it in your fab shop, install the biomass system within it, run it up, test it, evaluate it, configure it, and it's ready to go. Installation can be as little as a day on site, because typically a containerized system needs only a flow and return pipe and a 110 power supply. So it's really a quick process. There are also issues with regard to installation. If you want to place a plinth down there, that's fine. If you don't want a plinth beneath the unit, in some cases, certainly in the UK, we've installed containerized systems with biomass systems internally. Half of the container is a fuel store. So the back end of the container is full of wood pellets. The other half of the container actually has the biomass system in it, and it's sitting on movable ground. Some of the mining areas in the UK, the ground is very fluid. Even if you place a plinth down, it will still move. So we install those units with flexible couplings, and then the container can be used as need be. Readily mobile. I mean, a lot of these things are being used as pilot-based projects. We've got about 4 in Scotland that are being implemented and used up there now. Those locations are a test process. So they'll be being used for maybe a 6-month period, and then that container will be lifted and removed, and then a larger system will be implemented. It gives the school board, or it gives the local municipality or the town or city the opportunity to test and trial a system process. So they're trialing for the local town the possibility of using biomass. Does it work for them? Is it better to take a containerized system and spend maybe $100,000 and actually say, yes, it worked, or no, it didn't? Or is it better to spend $2 million and say, yes, it did, or no, it didn't? It's bad news if it didn't work. If it does work in a containerized system, you can actually lift that container out and use it on another building within the area. So it's a transportable object. There's no real hard work to move it to somewhere else. We've actually done processes where we've had a single organization, an area board, take a container, place it in one location as a pilot. After 3 months, they extrapolate the data for the rest of the year, that then move that container to another building, a different type of building. A sports hall has a different heat curve than an office block. So they actually have done 3 or 4 pilot tests in a 1-year period. It gives you much more bang for buck, as it were. Flexible utilization. I mean, in essence, with a containerized system, you don't have to build a building. In Canada at the moment, there's an oddity where the insurers actually think that a steel box outside of a building is more of a risk than if you put the whole thing inside the same building. It's about for a private individual, I think it's about $50 a year as a difference. Months ago, if you asked them about biomass systems and what the policy change or cost would be, they would say, bio what? But now, even if you walk into cooperators, they'll tell you, yes, we have a rate for it. So biomass is becoming visible. Parallel installation. As part of the pilot schemes that we look at, typically we don't often recommend that someone extracts an entire biomass system, or extracts a previous system, and replaces it with a biomass system. There are issues with that. There are PR issues if you have to have downtime on your biomass system. So you're actually better off if you tee into a hydronic system, so you have a pair of couplings that come off, keep the current boiler system running, and then bring the 2 T's off, so you've got flow and return power, heat going into the system. You can then switch over between them as and when you wish. So if you want to do a service, or if you've got to do evaluation as part of your pilot scheme, you can turn the system back over so it's running on its original gas or oil boiler. It's feasible to do that. Costings. Typically, a containerized system is a cost saving. Certainly, I need to do the full numbers within Canada, but building structures and integration inside of Europe, typically a hard, solid building is going to cost you far more than a container system will. So you can implement and use the system and move as you wish. So costing is a plus. These are some samples. Some of them are Canadian samples of containerized systems. The item here, large hopper there, I mean that big section is actually a pellet system. I believe that's up in Yellowknife. And I think that's a 300 kilowatt system, so 900,000 BTUs, I think. This is, again, this container is actually implemented on the side of a building. This is in, I believe, Austria. This is the internals of that unit. It was implemented and loaded in there. I think the site installation time on that was 2 days. So it's a fast process. The good news is that that system was pre-tested before it went there. And again, with the schools and the systems that we've implemented in Scotland, typically, I mean, we all grant that England is this tiny little speck on the map somewhere, and that Scotland's an even tinier speck on the map. But to do any job in Scotland, typically, if you haven't got that specific screw or that piece of kit, it's a 4-hour drive. Canadians know that all too well, right? So implementation and preloading the system and getting it ready is an important thing. Again, greenhouse-based system. What you're seeing here is the back in the container, a cyclone that collects the ash. Again, here, this is a container that's been split. The lift lid on the back is actually a pellet loading section. There are numerous ways you can deliver pellets. In most of Europe, it's a blown system, but in some places, certainly the UK, Scotland, and the other places, you don't always get a blower truck. It's like a big oil truck with a fan on the back. With these, you can actually set a bank. You can build a bank and actually place your container into the side of that bank. So your truck can actually tip up and load into the top of this, so there's no manual handling. One of these units are, if you took the Brandel system from outside, you could run maybe for 4 months on a container split like that. So it's an easy way of delivering it. You don't have multiple deliveries. So, Canadian biomass systems are available. I know the Brandel guys have spent a lot of time, maybe in closing on 4 years now, of working and looking at the European market. The key thing for Canada, whether it be the guys from Brandel or you guys, the key thing is that the European market is maybe 15 to 20 years out in front. The issue is that they're all very ready in Europe to come to Canada and share that technology. So it's feasible, it's quite feasible for you to cherry pick the technologies out of Europe and Scandinavia, and it's a sensible way to do it. There's a lot of technology there, and you don't have to start at square one. Good for Canada. One of the issues about biomass that always strikes me in Canada is, yes, there's a lot of fuel, yes, there are issues about how we achieve getting that fuel, and in many cases, I mean, I went to South River quite recently, and in South River, they actually have someone there that has a wood chip capability. Well, if you're going to supply heat to a building and you do it with oil or you do it with gas, pretty much the money you pay for that oil and gas has either gone out of the country or it's, you know, a lot of the money is out of the country. If you're actually paying that money into the local economy, most of that money stays local. We've talked about that already. The local plus of dropping money into biomass in a local business means that money stays local. Pilot and small projects are really important. Part of the thing that is difficult is when you're a mayor of a town, or whether you're in a situation where you're the decision maker, you need to justify what on earth you're doing. To stand in front of a town or a board and say, look, we're going to implement this thing, we're concerned about future security of supply, we're concerned about heat issues, we're concerned about costs on fuel. The big thing is, if you can put a price in front of someone and say, okay, here's a $100,000 project, this is what we can do, then you're actually being attentive to the situation. If it is not going to work for you, it is $100,000, and that's a lot of cash, but it's certainly not $2 million. And to prove the technology on a small scale from a project like a pilot and then upscale it is not an issue. It's the concept and it's the perception of the local people, the fact that they look at the flue and see that there is no smoke. They understand there are not particulates there, and it's easy to work with. Off of the back of that, larger biomass projects happen. Because if you've proved that fact, and you're deemed to be a good neighbour, then it's acceptable that you do larger projects. Once you can prove it and you've got real world numbers in the town or in the municipality or in the business, and you've got the real world numbers that actually prove this is a working and cost sensible system, then you can increase the size of projects and they will come. The issue has been raised about fuel quality, and it's key. If you have all the technology in the world and you have no fuel for it, it's no benefit to anyone. We saw in North Bay last year big space in the amount of fuel that was available. There were people chasing around all over the place, trying to buy it from, Quebec and all over. Even now, people are dragging fuel hundreds and hundreds of kilometers just to use it. So there's a tipping point that says when you have enough in the way of equipment and the fuel there, then you'll start to get a sustainable supply chain. But realistically, it's early days yet. The key for all of this stuff is about trying to move a project forward, whether that be a single project in one location or multiple projects. Unless people actually see this stuff implemented, there'll be no conviction for anyone to spend money anywhere else. No one wants to be first. And it's quite clear from the Massachusetts side of things, with the right direction and the right process and the right authority and regulation, the change can be made. It's still a PR battle and it's still a big issue, but it is something that can be done. And the more and more we look at these numbers, and you only have to look at the numbers from last year to this year that we saw in the presentation at lunchtime, the numbers are ridiculously huge. They're becoming massive. This is a big, big potential. I thank you for your time.